Imagine holding a spoonful of material that weighs more than a mountain. It sounds impossible, but this is the reality of neutron stars. These cosmic objects are so dense that their mass is packed into a tiny space, making them some of the most extreme entities in the universe. Today, we'll journey into the heart of a neutron star and discover what makes them so fascinating. Let's start by understanding how such a dense object comes to exist. Neutron stars are born from the explosive death of massive stars. When a star much larger than our sun reaches the end of its life, it explodes in a supernova. The outer layers are blasted into space while the core collapses under gravity. This collapse squeezes the matter so tightly that a neutron star forms, a tiny object with more mass than the sun but only about the size of a city. This transformation is both violent and awe-inspiring, setting the stage for the extreme physics inside. During the supernova, gravity wins the battle against the star's internal pressure. Everything is crushed together and the core shrinks dramatically. The result is an object so dense that its atoms are forced into new arrangements. This process creates the neutron star's unique structure with matter pushed to its absolute limits. The collapse is so intense that the star's original identity is lost, replaced by something entirely new and mysterious. Neutron star is only about 20 kilometers across, roughly the size of a city. Yet it contains more mass than our sun. This means its density is off the charts. If you could somehow scoop up a spoonful of neutron star material, it would weigh billions of tons. This extreme density is what makes neutron stars so intriguing to scientists and astronomers alike. Inside a neutron star, matter is organized in layers. Each layer is pushed to its absolute limit by gravity and pressure. The outermost layer is a crust, followed by deeper regions where the physics becomes stranger and stranger. Scientists study these layers to understand how matter behaves under such extreme conditions, hoping to unlock secrets about the universe. Surface of a neutron star is called the crust. It's made of tightly packed atomic nuclei and electrons. This crust is incredibly solid, far stronger than anything found on Earth. Imagine a material so tough that it could withstand pressures millions of times greater than steel. This crust forms the boundary between the star's extreme interior and the universe outside. Neutron star's crust is so strong that it's almost unbreakable. Scientists believe it could support mountains just a few centimeters high, despite the star's intense gravity. This surface is unlike anything we know, offering a glimpse into the power of extreme physics. It's the first layer you'd encounter if you could visit a neutron star. As you move deeper into the neutron star, the pressure increases dramatically. Atoms can no longer exist in their normal form. Electrons are squeezed into protons, creating neutrons. This process transforms the star's interior into a dense neutron-rich environment, unlike anything found elsewhere in the universe. Deeper layers of a neutron star are filled with what scientists call a neutron soup. Here, most particles are neutrons, packed so closely together that they form a unique state of matter. This neutron soup is incredibly dense and behaves in ways we're still trying to understand. It's a region where the rules of physics are pushed to their limits. Name neutron star comes from this dense neutron soup. Most of the matter inside is made up of neutrons, which are neutral particles found in atomic nuclei. This abundance of neutrons gives the star its name and its unique properties. It's a reminder of how extreme conditions can transform ordinary matter into something extraordinary. In the inner layers of a neutron star, matter behaves in ways that defy our understanding. Scientists believe these regions may contain a superfluid, a state of matter that flows without friction. Imagine a liquid that never slows down no matter how much you try to stop it. This superfluidity is one of the many mysteries hidden inside neutron stars. Superfluid matter inside neutron stars is unlike anything on Earth. It flows perfectly, never losing energy to friction. This property could affect how neutron stars rotate and how they emit signals into space. Scientists are still studying this phenomenon, hoping to learn more about the fundamental laws of physics. As we move toward the core of the neutron star, the mysteries deepen. The pressure and density become so extreme that even neutrons may break down into smaller particles called quarks. This transformation could create a new form of matter known as quark matter, which scientists are still trying to understand. Quark matter is a theoretical state where neutrons split into their basic components, quarks. This state may exist at the core of neutron stars, but it's still a subject of research. If confirmed, quark matter would represent one of the most exotic forms of matter in the universe, offering new insights into how particles behave under extreme conditions. The core of a neutron star may contain forms of matter we haven't discovered yet. Some theories suggest exotic particles or states that go beyond our current understanding. This unknown core is a frontier for scientific exploration where every discovery could reshape our view of the universe. Neutron stars have gravity millions of times stronger than Earth's. If you could stand on one, you'd be instantly crushed by the force. This intense gravity shapes everything about the star, from its structure to its behavior. It's a reminder of how powerful the universe's forces can be. The surface gravity of a neutron star is so strong that nothing can survive on it. Even the tallest mountains would be flattened and any object would be crushed instantly. This makes neutron stars inhospitable but also fascinating for scientists studying extreme environments. Neutron stars act as natural laboratories for scientists. They allow us to study matter, gravity, and physics at their most extreme. By observing neutron stars, researchers can test theories and discover new phenomena that can't be recreated on Earth. Let's recap the layers inside a neutron star. At the surface, there's a solid crust made of atomic nuclei and electrons. Beneath that, a sea of neutrons forms the bulk of the star. At the core, exotic and possibly unknown forms of matter may exist. Each layer is shaped by intense gravity and pressure, creating a structure unlike anything else. The crust is made of atomic nuclei, clusters of protons and neutrons. These nuclei are packed tightly together, forming a solid layer that's stronger than any material on Earth. This layer is the first barrier against the star's intense gravity. Electrons are also present in the crust, squeezed tightly alongside atomic nuclei. Their presence helps balance the forces at play, creating a stable surface layer. This combination of nuclei and electrons is unique to neutron stars, adding to their complexity. Pressure inside a neutron star is unimaginable. It forces atoms to break down, transforming matter into new forms. This pressure is what drives the creation of neutrons and possibly even quark matter. Understanding this force is key to unlocking the secrets of neutron stars. Electrons are squeezed into protons, turning them into neutrons. This process is called electron capture, and it's responsible for the neutron-rich environment inside the star. It's a fundamental transformation that shapes the star's interior. Neutrons inside the star are packed so tightly that they form a unique state of matter. This packing is far beyond anything seen in normal materials. It's a region where quantum mechanics and gravity interact in complex ways. Superfluidity means matter flows without friction. In neutron stars, this could affect how they rotate and how they emit signals. Scientists are still exploring how superfluid matter behaves under such extreme conditions, hoping to learn more about the universe. Neutron stars emit signals such as pulses of radio waves. These signals are affected by the star's superfluid interior and intense gravity. By studying these signals, scientists can learn about the star's structure and behavior. Neutron stars often rotate rapidly, sometimes hundreds of times per second. This rotation is influenced by the star's superfluid interior and its extreme density. Understanding how these factors interact is a major challenge for scientists. The core of a neutron star remains a mystery. Scientists aren't sure exactly what happens at these depths. Theories suggest quark matter or even more exotic forms, but direct evidence is hard to obtain. This uncertainty drives ongoing research. Neutron stars push the boundaries of science. Researchers use telescopes and detectors to study their signals and structure. Every new discovery helps us understand the universe's most extreme environments. Gravity inside a neutron star is so strong that it warps space and time. This effect is predicted by Einstein's theory of relativity. Studying neutron stars helps scientists test these theories in real-world conditions. The intense gravity of neutron stars bends space and time around them. This warping affects how light and signals travel, making neutron stars important for studying the universe's structure. If you could stand on a neutron star, you'd be crushed instantly. The gravity is so strong that it overcomes all resistance. This crushing force is a defining feature of neutron stars, shaping their structure and behavior. Some neutron stars have magnetic fields billions of times stronger than Earth's. These fields can affect the star's signals and even create bursts of energy. Magnetism adds another layer of complexity to neutron stars. Some neutron stars are called pulsars. They emit regular pulses of radio waves like cosmic lighthouses. These pulses help scientists study the star's rotation and internal structure. Pulsars send signals across the universe. By measuring these signals, scientists can learn about the star's rotation, magnetic field, and internal structure. Pulsars are valuable tools for exploring extreme physics. Neutron stars are much smaller than normal stars but far denser. Comparing their size and mass helps us appreciate how unique they are. A neutron star's mass is packed into a tiny space, creating extreme conditions. Imagine a star the size of a city but with more mass than the Sun. This comparison highlights the extreme density and compactness of neutron stars. It's a scale that's hard to imagine but crucial for understanding their nature. Neutron stars are the remnants of supernova explosions. These violent events mark the end of a massive star's life and the beginning of a neutron star's existence. Supernovae are among the most powerful explosions in the universe. After a supernova, the star's core collapses. This collapse is so intense that it creates a neutron star. The process is a dramatic transformation, turning a massive star into a tiny, dense object. Neutron stars push matter to its absolute limits. The intense gravity and pressure create states of matter that don't exist anywhere else. Studying these limits helps scientists understand the universe's fundamental laws. Some theories suggest neutron stars may contain exotic forms of matter we haven't discovered yet. These possibilities make neutron stars exciting targets for research, as every new discovery could reveal something unexpected. Neutron stars help scientists test theories about gravity, matter, and the universe. Their extreme conditions provide a unique environment for experiments and observations. Every study of neutron stars brings us closer to understanding the cosmos. Neutron stars are like natural laboratories, allowing scientists to study the most extreme physics. Their unique properties make them invaluable for research, offering insights that can't be gained anywhere else. Neutron stars represent the extremes of the universe. Their density, gravity, and mysterious interiors challenge our understanding of physics. By studying them, we learn about the limits of matter and the power of cosmic forces. Neutron stars are among the most fascinating objects in the universe. From their solid crust to their mysterious core, they push the boundaries of science and imagination. As natural laboratories, they help us explore the most extreme physics and unlock secrets about the cosmos. The journey inside a neutron star is a journey into the unknown, filled with wonder and discovery.